mobile apps, yoga trainer case study. Pretpostavljam da sada možemo, tako?
Da. Greetings,
Evo,
everyone.
izvolite. Čekamo da podelite ekran i da krenete.
Okay. Can you see my screen now?
Vidimo i čujemo.
Okay. Hello everyone. I'm Nenad Petrovic. I'm a teaching assistant from the Faculty of Electronic Engineering, University of Niš in Serbia, Department of Computer Science. And now I will present you the paper that we wrote together with Masha Radenkovic, who has just graduated in software engineering at the same faculty. And the results presented in this paper are partially contained in her master thesis. And the second author is Professor Valentina Nejkovic, who actually was an advisor of this thesis. When it comes to paper writing, I also helped her as a student to actually round up some of the results in a paper with some additional observations that we later in our lab managed to see. So in recent years, we are all witnessing that the increasing capabilities of mobile devices have led actually to adoption of multimedia in many areas on these small portable devices, from education to healthcare. We have countless use cases where we can actually benefit from this processing power in our pockets. However, when it comes to concept of augmented reality, the main idea is to merge realistic scenery, commonly coming from camera, with interactive virtual 3D objects that appear on the screen in some particular context, while different outputs as a result of this interaction are produced, such as text, images, sounds, or animations. This concept has been successfully applied also in fitness mobile applications, which is actually the topic of our paper, adopting augmented reality and deep learning for gamified fitness mobile apps. And the case study application is actually Yoga Trainer. So, furthermore, you can see in our title, gamification. Recent studies show that more than half of the currently available fitness-oriented applications in mobile phone application stores, such as Google Play and App Store by Apple, actually contain at least one element of gamification. The origin of popularity regarding the gamification approach comes from around 5 years ago in this area, when a popular game Pokemon Go emerged, where users actually are motivated to walk around in the city and pass a larger distance and be physically active in order to collect creatures that can be later used for battles and some other activities in game. So this approach has shown very good results, causing people to walk more, to be physically more active. So there emerged also a bunch of other applications who in some other way maybe adopted the gamification approach. So there have been also the apps where users do exercises by moving the parts of their body. So these movements are further used in augmented reality applications as some kind of input in order to control characters, to collect some items, or so on. Therefore, in this paper, we explore the potential of adopting augmented reality in fitness mobile applications together with gamification approach, but integrating with deep learning as well. So this is something that is still not explored as much as augmented reality fitness apps. The integration with deep learning also gives us endless capabilities when it comes to different kinds of predictions that can be useful some way in our gamified fitness app. As outcome, we propose virtual yoga instructor application, mobile application with gamification elements. It relies on ARJS augmented reality web-based framework for marker-based augmented reality. On the other side, PyTorch framework for Python was used for implementation of deep learning image classification model, which is based on convolutional neural network in order to classify the images of users doing exercises like yoga poses. So if the correct pose was shown by the user, then she or he will get points as a reward. This is actually the goal of convolutional neural network, to recognize whether the pose matches with the expected outcome. When it comes on the other side to user interface and business logic, we adopt AppSheet and AppScript frameworks which give the ability to rapidly develop complex mobile applications without using a bunch of code. Like on one side, AppSheet gives the no-code approach for user interface generation, while AppScript is quite
Che ti ho
simple.
incrociato?
Uh, can you hear me? Moreover, we have lightweight based framework, which is called ARJS, that gives us ability to actually have augmented reality applications on our mobile phones run in a web browser. So it's based heavily on JavaScript and HTML for development of both location and marker-based augmented reality applications. So it integrates camera stream capabilities, visualization and rendering of 3D primitives, graphical transformation, model handling and loading, animation of these models, basic marker recognition, and GPS location handling. In this paper, we focus on marker-based augmented reality. The intuitive syntax of this framework is based on special HTML tags. The highest level entity is scene, that consists of camera stream with additional 3D objects that appear over it. Inside the scene, we have markers which trigger the objects that appear beside the markers. And in order to actually uh, have some specific models assigned to these markers, we need to use entity HTML tag inside the marker and provide the specific 3D primitive like box or some other shaped sphere. Or what we use actually in this paper is model loading, GLTF format, which is suitable for web-based application. So we specify GLTF model for entity, and this attribute refers to path where the model is contained. Now we can see an excerpt of a code showing how minimal augmented reality marker-based application can be defined using ARJS framework. So we have a scene. Inside that, we have a marker, like up to n markers. The preset that we use is kanji, a well-known marker beside hero. This is something like, to say, prototype, often used as prototyping markers, but when we have a larger number of markers, we can also use numeric barcodes or specific custom images. Also, we have a entity camera, which is actually helping us to use the camera stream from our mobile device. And also, this is contained in HTML body. So we can have, for each marker, we assign a distinct model. This entity is GLTF model called scene.gltf. And apart from the path to the model, to this entity, we also assign a event handler in JavaScript, which is triggered when we click on this model. So interaction of some kind, like touching the object, can cause the output in the application. When it comes to background further, we'll quickly go through convolutional neural networks. Their goal is actually an image they're heavily leveraged in image classification to extract features, the so-called feature maps from raw images. And this way, we don't use all the data coming from pixels, as images can be quite large nowadays. And we only use the most relevant features for the classification in the other part of neural network that is based on multi-layer perceptron and performs classification. Moreover, these convolutional layers in a neural network, actually what they do is they learn the filters, the so-called kernels, that are as suitable as possible for a specific type of classification. And in each iteration of training, they actually tune these kernels to be better for specific tasks. When it comes to parameters of convolutional neural networks, we have depth, which is the number of filters used for convolution, stride, which is number of pixels between two signatures of convolution filters applied over the input image, padding, and adding zeros around the corner. and kernel size, which are the dimensions of the applied convolutional filter. Additionally, different types of layer like pooling or dropout can be used in order to fine-tune and increase the performance of the neural network, as, for example, pooling layers only keep the relevant features and reduce the image size, so processing times can be better. So you can see here the visual representation of how kernel of size 3 times 3 is applied on input image 5 times 5, and the feature map is performed, while the input sizes in the next layer are actually calculated using this formula. So when we have specific input length, kernel size, padding, and stride, we use this formula to calculate what the output after applying the specific kernel with these parameters would give. Moreover, in this paper, we rely on Flask for integration of mobile app with convolutional neural network deployed on Google Colab environment performing image classification. So actually, one thing that I forgot to mention is for convolutional neural network, we rely on PyTorch for implementation. Maybe I said that in the introduction, but I will also mention here. And Flask is a Python framework that gives us ability to actually deploy REST API-based web services in Python. So here, what we do is actually we route specific prediction methods of our pre-trained classification model. We already trained the model. After that, we make a service like Yoga Classify that receives image as an attachment of post request, sent by a mobile app, and we extract the image, convert it to a suitable format, and forward it to a neural network that is already trained. So after as outcome of prediction is a class of a pose, like which one of 5 possible yoga poses is actually shown on this image. As outcome, it's returned the number of poses returned as HTTP response and converted to string. Now let's take a look at the overall architecture of our system. So when it comes to mobile app, we have AppSheet for interface, for screens and forms where users see information and provide input like images of themselves doing some yoga pose or exercise, and ARJS, which is actually a marker-based augmented reality framework. So user walks around, has this camera stream detecting markers, clicking on them, redirection to AppSheet interface for image submission is actually done. When it comes to backend logic, we have AppScript, which is a JavaScript-based framework deployed completely on Google's cloud resources which actually integrates different G Suite services like Google Drive, Mail, Gmail, and Google Sheets. And when it comes to predictive model, I already mentioned we deploy our PyTorch image classificator in Google Colab environment. And for integration between the mobile app and the prediction model, we use Flask API from AppScript backend logic in Google Cloud Services. HTTP requests are sent to Flask, which are returned back. So these results can be leveraged in order to actually update the data in Google Sheets, which are used as a storage. So all the data for the app is stored in Google Sheets, as AppScript has very simple integration with it. Google Drive is used for storing images and all the data within Google Sheets, and Gmail is used to generate coupons as a rewards to the users who perform a correct exercise. So these discounts can be further used for some products, for example. When it comes to image classification model, here the architecture of convolutional neural network is described. In this table, you can see that we have 5 hidden convolutional layers for feature map extraction, where each of them is followed by batch normalization, ReLU activation, and max pooling. Additionally, except the first layer, we also have a dropout layer before normalization, and the role of this layer is actually to promote the independence of feature maps by randomly setting some of the input channels to 0 with some predefined probability P. Here you can see the probabilities used for different dropout layers. And finally, once we extract the features by our convolutional layers, 5 hidden layers, we actually forward this flattened feature map as a one-dimensional vector to a multi-layer perception, which performs classification tasks. And it has 4 hidden layers. In the output, for that purpose, we have actually 5 softmax nodes. Actually, we have a layer with 5 nodes doing softmax, as there are 5 different possible classes of yoga poses. Um, so it's common for classification task. But one more thing which is here important to mention, that all the images from the data set are resized first to these dimensions, 256 times 256, to avoid long processing times. If when it comes to mobile app, now we'll see how it works quickly. So user walks around on some markable places in around the touristic destination, for example, as this application could possibly used also as a tourist guide, additional tourist guide, motivating people to be physically active. And near some archaeological site, building, statue, monument, user can find the marker, turn the camera to the marker, and 3D model of yoga fitness instructor showing specific exercise pose appears. The object itself is animated and interactive. If we click on it, we'll be redirected to AppSheet page showing the input form, where we should provide our image of doing the yoga pose in order to actually check whether we perform the correct exercise or no. If we have a correct pose within the user provided image, uh, the the points for that user would increase in the Google Sheets document. So therefore, we can later use these points for claiming some prizes or rewards, like digital coupons, which are sent to the user. Like they require a specific amount of points, like 5, 10, or something like this, and receive it using Gmail. Here is a very quick demo of what the application does, like accessing the GitHub pages, hosting the server, 3D model appears, we click on the model. After some time, the redirection to AppSheet screen appears, so user can actually provide an image showing her or himself doing the yoga pose. Like here are the points before providing the image for the first user, and after that we provide an image showing the correct pose. Here, like selecting this pose, sending the HTTP request. AppScript takes from Google Drive the image that we provided by AppSheet application here, and sends HTTP request. So we can see that from 17 points before, we now have 19 points, means that user provided the correct image. So in this case, like we had that AppScript trigger activated when we provide the image, took the image from the Google Drive and redirected it to actually Flask API call, where classification model actually takes the image and gives the output. Now let's see the experiments and evaluation. You can see the equipment used for this purpose. We had 5 yoga poses. Here are the possible dataset images, types of poses that we have here, coming from publicly available open dataset available on this location on Kaggle. There are 1,551 images, 80% is train set, and the remaining 20 are the test set. We achieved up to 71% correctly classified examples, and here you can see also the graph how the accuracy, the number of correctly classified examples in this case, increases as the number of epochs in the training grows. Moreover, we also evaluated response time of the application on this configuration on Redmi Note 8 device. Price claim using AppScript trigger. When user has enough points, it lasted around 1 28 seconds. Moreover, we have longer times for post check and image classification, as image has to be uploaded, forwarded to Flask API, and so the result can be obtained using the neural network. It lasts a bit more, as we have also the upload of image and invoking of Flask API service. And here are the times for prediction and for GPU and CPU training. Um, so you can see that in Google Colab, we achieved quite good results using GPU, as it gives the ability to use for free some of these devices randomly allocated in free version. So to sum up, in this paper, we have shown how augmented reality fitness-oriented mobile app can be integrated with services that actually leverage deep learning for image classification. Furthermore, we actually provided a distinct model used for image classification, which can be customized for different types of images and classifications, not only for yoga. In this case, we customized the parameters experimentally in order to achieve these results, but it's quite easy to extend this work for any other type of images, like to recognize different species of fish or something else. And when it comes to proposed set of technologies, what is remarkable is that we relied on free cloud technologies that don't actually, we rely on Google's infrastructure in most cases without spending anything, but we have certain limits, like the number of users. So for commercial releases, a different approach could be used for a larger number of users, but for smaller applications, this set of technologies is quite flexible and easy to use, and gives quite quickly good results, even when it comes to performance. In future, we plan to explore the potential of integrating fitness applications further with sightseeing tourist applications, especially regarding the deep learning adoption in context of post-COVID-19 tourism. Thank you for your attention.
Hvala za prezentaciju.